And next I am going to discuss about the mathematical problem on the exponential growth, and formula is nt equal to n0 e to the power capital rt. Okay, and nt is the population at time t, n0 is the initial population, r is the growth constant, now it is exponential growth constant, and t is the time. Okay, and now problem number one is the increase in population from 1 million to 10 million took 200 years, comma exponential growth at constant rate, find out the growth rate. Okay, next we have to find out the growth rate constant. That means growth rate constant means capital R. Okay, so now from this equation 1 million to 10 million, so that means initial population is 1 million, and at after time t, that means what time means 200 years. After 200 years, and this population goes to 1 million to 10 million, and this is the nt value. Okay, so now nt equal to 10 million and n0 is equal to 1 million, t equal to 200 years, and now we have to find out the r. So simple, this is a simple problem. Also now put all these value in in this equation and get the value of r. Okay, and now always you have to find out the r value, always percentage. Okay, now from this calculation you have to find out the value is, that means value of r is 1.152 percentage. Okay, and now same type of problem in India, the increase in population from 33 billion to 120 billion took 600 years. For exponential growth at constant rate, what will be the growth rate? Same equation, same problem. So now in that case 33 billion to 120 billion, now 33 is the initial and 120 means nt, and t is the 60 years. Now all these values putting on that equation and get value of r, and from this equation we get the value of r value, we get the value of r, and now the r value is 0.0215, and next if we take percentage, then is the value of r is 2.15 percentage. And now these two problem based on the exponential growth in continuous method. Okay, but in case of non-continuous method, in that case the formula is nt equal to n0 1 plus r to the power t. Okay, so first problem is in 1990 India produced 2 into 10 to the power 10 kilowatt hour of electricity. The average annual growth rate of electricity demand in the previous 20 years was about 0.9%. Estimate the electricity consumption in 2020 if the 0.9% growth rate per year remain constant over these 30 years. So how can you differentiate which one is continuous and which one is non-continuous? In non-continuous growth rate always constant, but in case of continuous, growth is not a constant. So now in that case growth rate in that case remain constant over the 30 years, that means 199 to 220. Now this equation, now this mathematical is based on the non-continuous growth rate equation. Okay, so now nt is the amount after t years, n0 means initial amount, and r is the growth rate. Okay, so now in this case nt is equal to that means n30, that means after 30 years what is the value of electricity consumed. Okay, now in that case n0 means initial electricity consumption, and in electricity consumption is the 2 into 10 to the power 10 kilowatt hour. Okay, now r is the value, r is the 0.9%. now this is the percentage value, so what is the actual value? 0.9 into 100, so that means 0.009. Okay, that means 0.9 भाग x 0.9 percentage to 0.9 divided by 100. Okay, so now in that case this value is 1 plus 0.009, and t is equal to 30 because the difference is 30 years. So now from this from this value we get the value of 2.62 into 10 to the power 10. That means after 30 years this amount of electricity is consumed. Okay, next problem. Same type of problem. In that case, in 1986, the United States produced 2.4 into 10 to the power 12 kilowatt hour of electricity, and the average annual growth rate of US electricity demand in the 15 years after the 1973 oil embargo was about 2.2 percentage. That means this is the growth rate, and estimate the electricity consumption in the 2086 in 2.2 percentage per year growth rate remain constant. That means in that case growth rate also constant remain constant. So that means this is also non-continuous growth. So that means same problem is same. That means nt equal to n0 is 1 plus r to the power t. Same formula. Nt means in that case 100 years. That means in 100, because 1986, and you have to estimate the 2086. So n0 value is 2.4 into 10 to the power 12 kilowatt hour per year, and r is equal to 2.2 percentage. That means 0.022, and t equal to 100. Now from this value we get from this value we get the value of n 100, and n 100 means after 100 years. That means 2086, the electricity consumed in USA is the 21.1 into 10 to the power 12 kilowatt hour per year. Okay, understand?